Hello everyone, I am back with a new interesting video. In this video, we are going to learn about physics. In this video, our topic is physics. I am back with a new episode of physics series, which is episode 2. And in this video, in this episode of physics, we are going to learn about Newton's 3 laws of motion. Newton's 3 laws of motion. There is no person who don't know this. Yes, every person knows this topic, Newton's 3 laws of motion, and every student tries to understand it, but they can't understand, they will not understand. Yes, in this video I am going to make understand this 3 laws of motions clearly with examples. Okay, so without a delay, let's get started. And firstly, Newton's first law of motion. N means Newton, okay? Newton's first law of motion. Okay? What is Newton's first law of motion? The Newton's first law of motion states that every object continues to be in rest or in state of motion until a net external force is applied. Do you remember which law also states this? Every object continues to be in rest or in the state of motion unless until a net external force is applied. Again, which law states this? You are really correct. It is even inertia states this, law of inertia. Law of inertia also states the same statement, and that is why Newton's first law of motion is also called as law of inertia. If you say law of inertia, every person says the Newton's first law of motion, because the statement of law of inertia and first law of motion is same. And that is why Newton's first law of motion is also called as law of inertia. Are you clear about this? I will give a little example. There is no need of example because there is a car and bus example. Yes, there is a example of car and bus which I have already explained at the starting, which is first episode of physics. Yes. If the bus driver applies accelerator suddenly, for example, not only car and bus, every time let's take one stone, big rock. See, let's take it is in rest. Yes, it continues to be in rest. It wants to be in rest. An external force, when we push with our hands, I don't know to draw hands on the board. Okay, so when we push with our hands, what becomes a slightest acceleration, a slightest movement is observed in a rock. Yes, when we push hardly rock with a great force, yes, it moves. Yes, why? Because of the force applied. Yes, see, this wants to be in rest. Till when it wants to be rest? Unless until a net external force is applied. Yes, it wants to be in rest unless until an external force or net force is applied on it. When an external force is applied, net external force is applied, again it wants to be in motion only. When it is in motion, when we push it, when it is in motion, again it wants to be in motion. Unless again an net external force is applied again. Then again net external force is applied from opposite direction. it again comes into the back, it comes back into the state of rest. And this is what the law of inertia or first law of motion states. Okay. So, I think you have clearly understood the first law of motion. If you have any doubt, no doubt, just post it in the comment section. Okay. So, and next, let's talk about Newton's second law of motion. Yes. Here don't be confused, N means nothing but Newtons. N means Newtons, okay. Newton's second law of motion. What is Newton's second law of motion? The rate of change of momentum. There is a new word introduced, momentum is directly proportional. Directly proportional to net forces acting on it, and it takes place in the direction of net force. This is the second law of motion. It is the rate of change of momentum is directly proportional to the net forces acting on it, and it takes place in the direction of net force. So, what do you mean by this? So, yes, what do you mean by this? See, for example, a kite is there, okay, one kite is there. See, a thread, you are operating that thread. If you pull this thread this side, this also moves this side. If you pull this side, it also moves this side. See, what we can conclude from second law of motion is the direction in which the net external force, the net force is applied, the object also reacts to the same direction. See, for example, okay, let's take cricket. Yes, there are so many people who likes cricket, including me. I really love cricket, okay. So, when we are pulling the shots, when we are playing the shots, yes, I don't want to say the names of shots. When you are playing the shots, at which direction you are hitting the bat, the ball goes on to the same direction. See, for example, you are hitting the straight drive, what it goes? See, you are pulling the bat up, so the ball also goes up. Yes, when you are playing a pull shot, you are pulling the bat like this, in this direction. Even the ball moves this direction. See, we can conclude that, we can conclude from second law of motion that the direction of net force, the object, the change in state of an object will be occurring on the direction of net force. Yes, the object moves according to the direction of net force applied on it. Yes. So, yeah, this is all about second law of motion. If you did not understand still, please post in the comment section. Okay. And our last one is N's third law of motion. What is Newton's third law of motion? The Newton's third law of motion states that for every action there is an equal and opposite reaction. You can understand very easily. Yes, for every action there is an equal and opposite reaction. Okay, see, this is really simple. This is really easy to understand. See, let's take rocket. Nobody is there in this earth who doesn't know the rocket. Everyone knows the rocket. Yes, Chandrayaan 2, Chandrayaan 1. Yes. So, taking the example of rocket, when the launching of rocket takes place, a higher flame will be coming out. Yes. See, flame will be pushing the rocket downward. Yes. See, flame will not move upward. Once observed in rocket, where the flame goes, it goes downward with a great force. Yes, but rocket moves upward. How? See, when fire pushes it downward. Yes, even rocket goes upward. How? As per the second law of motion, it should go down. That force. Yes, that is why Newton observed each and every subject, each and everything in a motion. And he concluded the three laws of motion very carefully. Yes, for every action there is an equal and opposite reaction. Yes. So, another example is skateboard. See, when you are riding the skateboard, you will not move frontward to move forward. See, when you are pulling the road backward, like this, it moves forward. Because why? See here, there is an opposite reaction for the action here. Yes, and another example is balloon. Yeah, balloon is really simple example. See, when you blow the balloon with a high pressure and when you release it, what happens? The air in the balloon releases and balloon goes forward. And this is another example. See, when air releases from the balloon to outside, from which direction the air releases? Backward? Yes. When air releases backward, the balloon goes forward with the same force. With the same force, it goes into opposite direction. Yes. So, that is what the third law, Newton's third law of motion concludes. For every action, there is an equal and opposite reaction. Opposite. See, it is when air is pushing backward, it is going forward. Opposite. And with how much force is air pushing backward? With the same force. Yes, with the same force, balloon goes forward. Yes, equal and opposite. Yes, and if you bounce the ball, hit the ball to the ground hardly, what becomes? It bounces back. Yes, if you throw the ball at 45 degree, it bounces back with the same angle of 45 degree, with the same force again. Yes, see, when you hit the ball hardly, yes, when you hit the ball hardly, when it bounces when it hits hardly to any wall, yes, when it hardly to wall, what happens? With how much force did the ball hit the wall, with the same force it bounces back with an opposite. Yes, so that is what here third law of motion concludes. Yes, so that is what the third law of motion concludes. So these all are about three laws of motion, Newton's three laws of motion. If you have really understood, I am really happy because you have understood with my explanation. And if you did not understand, no worries, I am not really sad, because when you don't understand, you will get doubts. Yes, such that you will learn more. Yes, so if you have any doubts, please post it in the comment section. So that's all about today's episode, guys. Thanks for watching. I'll see you in the next one, and with the leave signing off your logical brilliance. Thank you for watching.